Hi guys, it's Talha here again. So today what we are going to learn will be about some stats. So what we are going to learn today is going to be about the Poisson distribution, and Poisson distribution, and also if we have time, we are going to learn about some storage devices and system software, and specifically operating systems so if we are going to come towards our second topic, but for now let's stick with this our Poisson distribution. So in previous lectures I've explained what is binomial distribution, but today I'm going to discuss what is Poisson distribution. So Poisson distribution is nothing else, it's just binomial distribution. The only difference in Poisson distribution and binomial distribution is the total number of trials, or the total n. In binomial distribution you have a finite number of n, or finite number of trials. In Poisson distribution you have infinite number of trials, or you can say infinite n. So what do I mean by that? For example, in binomial distribution, if I say that I toss a coin 2 times, or I toss a coin 5 or 10 times, but there's no way for me to toss that coin 10 times in a single time. In a single time I can only toss that coin one time. So that is a finite interval. That is a finite interval of time where I toss a coin a single time. But here, if I give you an example of, for example, if I say that what is the probability, or how many cars pass through a certain area in 1 minute, or you can say 60 seconds. So here you cannot say that in a single minute the probability, or the only one car can pass in a single minute. No, because that will be wrong. You can have as many cars pass through a certain area as in a minute as you can, because there's no limitation. So if you want to solve this, you will say, oh, I can just make it more granular, or I can just decrease the time interval, and that will give me an accurate answer. So if you say that what is the probability, or how many cars will pass in a single second, but you will be wrong again, because 2, 3, or even 10 cars can pass through a certain area in a single second. And that if one car passes, or if 10 cars pass, both of them will be counted as a single success, as one success. And this will be wrong, because you want to find out what is the probability uh, of 10 cars passing through a time interval. But here, in a single second, if you have 10 cars pass through a certain area in a single second, you'll have only a single success. So if you keep dividing, or if you keep decreasing the time interval, you will eventually reach infinity. So that was the difference between a Poisson distribution, a Poisson model, and a binomial model. Binomial distribution, that in the binomial one you have finite number of n, or finite number of trials, but in a Poisson distribution you have infinite number of trials. So we have the formula for the binomial distribution is P of x equals x, and that is n choose x. P of x, p the probability of successes raised to the power of number of successes, and you have q, that is also known as 1 minus p, that is n minus x, the probability of failure raised to the power of number of probability of failure. So this is binomial distribution. And the mean or the expectation of the binomial distribution is expectation of x equals np, where this n is the total number of trials, number of trials, and your P is the probability of success of each trial. So this is the mean, and the mean of Poisson distribution can be calculated as lambda, or you can say mu. Mu will be more appropriate for now. So mu equals, you have mu equals, um, okay, so this is the mean of Poisson distribution. But if you want to say that Poisson distribution is somehow related with the binomial distribution, so you can say that mu equals np. So we are making an equation, we are making a claim that mu should be equal to np if this distribution is the binomial distribution. So you have mu equals np. So if you say that this, if you claim that this distribution is a binomial distribution, so if you, so p of x when x takes little x, so what you do, because in here, as I explained, as I just explained, that your n will eventually reach infinity, that the limit of n reaches infinity. So you have this formula. So if I write the formula for the combination or the coefficient of binomial, the formula for the binomial coefficient is n factorial divided by n minus x factorial, and you have x factorial separately, and here the limit of n actually approaches infinity. So this is the point to be noted. Here, if you calculate the do some math, you have probability of mu by n. So this is your probability, mu by n raised to the power x, and then you have 1 minus mu by n. You have 1 minus mu by n raised to the power n minus x, or yes, n minus x. So here, if you apply the, or here, this term, or this term, if you consider, so this term, if we consider, so you have p of x when x equals little x, you have limit of n approaches infinity. When limit of n approaches infinity, you have n factorial divided by n minus x whole factorial, x factorial, and you have mu, mu by, what was that, mu by n. You have mu by n to the power x, and 1 minus mu by n raised to the power 1 minus x. So if you consider this term is actually equal to n minus x factorial. This term is actually equal to n multiplied by, or n into n minus 1 into n minus 2, and up to, so on, up to n minus x plus 1. This term is actually equal to this. If you calculate it, it's logically, and it's clear that this term can be written as this. So you have p of x equals x, and you can also prove it. You can also prove it for any number, and you will get this term instead. So this equals, so let me just put this value in place of this one. So I have n minus n into n minus 1, n minus 2, up to n minus x plus 1 divided by x factorial. I have mu, and what I can do, I can also write the powers separately. So you have mu power x divided by n power x, and I can also separate the terms, and each one is going to have the single power. So here you have 1 minus mu by n power, what was that, n minus x, so that will be n. So you have n and dot, or multiplied by 1 minus mu power n, and that is going to be power minus x. So what it means that, you know, if you multiply it, your powers are going to add, and that is going to give you the same very term. So this and this is the same thing. So you have x equals x, and now so actually this has limit 2, so limit x approaches and approaches infinity. So here all of this is actually equal to n power x, because it's going up to so on to n minus x plus 1, but that is n power x up to so on divided by, and I'm going to shift this term here, so you have n power x by n power x, limit of n approaches infinity, and you have mu power x, you have mu power x divided by x factorial, and you have you have uh, you have 1 minus mu by n power n, and then you have 1 minus mu divided by n power minus x. So if I calculate the limit, this is going to be 1. So you have x equal little x, this is going to be 1 into mu power x. You have mu power x divided by x factorial, and here this, okay, so this is very important. So this, if you apply the limit of n approaches, when limit of n, when n approaches towards infinity, and you have 1 minus mu by n power n, this is actually equal to the e power, you have e power mu, or e power this mu. So you have e power mu equals to, when n approaches infinity, of the function or of the term 1 minus mu by n whole power n, it gives you mu power n. It's mathematically calculated, so I'm not going to give you a proof, but you know, you've just got to know that this term is equal to this one. So you have this mu power x, you have this, and then this term is actually equal to e power, and here, you know, okay, so the 1 plus a by n, this is when this limit n approaches infinity, and this is actually equal to e power a, but here you have plus and here you have minus mu, so instead of e power a, that will be e power minus mu. So you have e power minus mu, and if you apply limit to this one, so you have mu by n, that will be 0 and 1 up to power infinity. That is actually going to give you no, here, so you have 1 minus mu by n, so mu by infinity, that will actually give you infinity, so that will actually going to give you 0, so 1 up to any power is 1. So you have so what is, hi guys, so where we left off was here. So here we left off in the previous video, so we came up to here. So what I was talking about, that this, if you apply the limit, this approaches when n approaches infinity, this equals to 1, and you have this equals, as I explained here, you know, 1 plus a by n whole power n, when limit of x approaches infinity, is equal to e power a, but here we have minus mu, so instead we write e power minus mu. So this equals to e power minus mu, and if you applied the limit over here, 1 minus mu by anything divided by infinity equals 0, so 1 to the power minus x, and 1 to the power 1 to any power is 1, so you have this also equals 1, and then you have p to x equals x, p of x, the random variable x, probability of any random variable x, equals the little x equals e power minus mu power x divided by x factorial. So finally we have gotten this formula. That is the formula, that is a very important formula for Poisson distribution, and it's very interesting as well. So if someone gives you some values, you can only just put those values in this formula, and there you go, you've got your uh, answer for the problem. So this is was all about Poisson distribution. And I think we have a little time, so we are going to discuss some storage devices. So in some previous videos I've also discussed some storage devices. Some storage devices we have I've discussed CDs. I've discussed CD-RW. That CD-RW means you can only write on that CD but cannot erase, you cannot rewrite. But in CD-RW you can actually rewrite and erase the content and rewrite on separate times. You have DVDs, the Blu-ray discs. You have many other yes, so this category is included in optical discs. Then you have many other storage devices. You have tape, you have magnetic tapes, you have you have micro fiche, where there are microscopic images on a strip on a film, and you can only read them through a microfilm reader, because these are microscopic and these are very small, so you cannot read them with your naked eye. You've got to use your microfilm reader for to read that stuff, or to see the images. For example, you can read newspapers, you can read books, you can read stories through these microfiche and microfilm through a microfilm reader. You have ATM cards, you have smart cards, which have a small type of memory chip embedded into the card, which have your personal information regarding your identity, regarding your accounts, your vaccinations, your health, and everything is stored in that memory chip that is embedded into the your smart card. So these were some of there are many storage devices, but I discussed some of them here. And then you have okay, so I can discuss here. You have system software. So what is system software? System software is any software that controls your operating system, that is related with the hardware, and that is related with your system unit. So that controls all of your system, that is required. That is, system software is actually required by your operating system to function properly, to perform the basic tasks. For example, you have turning on the computer, turning off the computer, you have updating apps, you have many more things related with your system software. And application software is actually the software. So you have system software, and then you have application. So system software is required by your operating system, and application software is required by your system software. And yes, system software is actually the interface between the application software and system software, or between you and the application software. Is the interface, or is the bridge. It's the bridge, in easy words, that is the bridge between you and your application software. So in system software, the most important one is our operating system. Operating system, as I stated, performs the basic functions of the computer: turning it on, turning it off, updating apps, and connecting to a network, and many more. So you have many operating systems, sometimes also called the platforms. So you have, for example, you have Mac OS, which I use, you have Microsoft Windows, you have Linux. So these are some of the operating systems or the platforms which you have currently in the market right now. And if you purchase if you purchase one is system and one is application. So if you purchase an application software in a package, so you've got to read first, for which platform it is made for. So if it's for Mac, it won't work on Windows, or if it's for Windows, it won't work for Mac. So the platform should match. The application software's platform should match with your uh, operating system. So it has many functions. Operating system has many functions, and we have got to study them in our next class. We were supposed to study them today, but our teacher didn't come today, so we skipped. So yeah, today we couldn't study them, but in a later video I'm going to explain what are the main functions of the operating system and why it is so important. For now, we just know that in operating system you have different platforms, that is Mac, Windows, Linux, and you have many more. Alright guys, so that was part 2 of the video. I hope you guys enjoyed the video. I hope it helped, and thank you very much.